So this is like the last class of the semester, and the main thing I want to teach you all today is learning from troubles. And so that little text message that just popped up is a friend of mine who was applying to Google, and he's the teaching assistant out at Fresno State. And anyhow, but he applied to Google, and Google said, I think you need a year or more of experience. And so I said back to him, sorry to hear that. Good news, bad news. You never know which it is. One door shuts and maybe something else opens, which will turn out to be way better. You never know. Don't get down on yourself. Go have a beer, then get back to your keyboard and start coding some more. Then we'll build something, and it'll be the classic great story. Google said no to me, so then I helped start a company, and 3 years later, I'm a millionaire. So, you know, learning from struggles, right? And this morning I got up, and my family's asleep, and so I started looking at Stack Overflow. And Stack Overflow has, you know, you could sign up to get questions about subjects you're interested in. And then those questions that people have posted, so I'm getting all the questions from Golang, and those questions that people have posted then get emailed to me, and I can look at where are people struggling. And I could maybe answer the questions, and that helps me by re-explaining something. So this is learning from struggles, right? So somebody's struggling, I look at where they're struggling, I help provide the solution, I'm teaching, that helps reinforce it for me. Or it makes me think about some aspect of the language I haven't thought about before, or or consider it from their perspective, or something I'm still learning, or something I already know, it reinforces it, all that stuff. Or I look and I see what somebody else answered, and I'm like, oh yeah, cool, that's a cool answer. So we're going to look at a couple of things I was looking at today, and a few things I learned with Stack Overflow. And I want to show you how to subscribe to certain topics in Stack Overflow. So I actually don't remember how to do this because I did it once and I subscribed to the Golang deal, and then I forgot how to do it, and I was looking for it, and it's not totally intuitive. So we're just going to do subscribe to topic Stack Overflow and see if a Stack Overflow post comes up about how to subscribe to tags via email, Stack Overflow blog, tag favorites and tag subscriptions. How do I find topics I'm interested in? So we'll just take a look at this. And I'm going to pause this video, so if you're watching the video, you don't have to watch the searching. We'll just show you the answer. All right, so that wasn't easy, and we just had to go watch a lynda.com video, which is walkthroughs and, well, it's Google Cloud Platform Essential Training with Lynn Langett, which is awesome. And it is this video right here. And in there, she talks about Stack Overflow, which is right there. And then even after watching that video, I'm like, I don't know where to go on that. But then one of the students in the class was like, well, right here, in Lynn's video, it's just the RSS. But when you hold your mouse over the tag for whatever topic you're interested in, you have subscribe. And so when I click subscribe, it subscribed me for email updates. So that's how you do it.
You have to confirm it on your email.
And then you have to confirm it on email. I'm not sure how, and this is kind of interesting, top users, that's cool.
It says you'll get an email every 24 hours.
Yeah, is there a way to manage that? Let's look at the email that came in. Confirm your subscription, email frequency every day. To change email frequency, or you go to Stack Exchange filters 2059 go. So let's go check that.
Are you recording again?
Yeah, thanks. I'm recording. And email updates every day to me. Email sent, please confirm. So I guess I have to confirm. There we go. And view the filter or change your email preferences. And so we could go to email preferences, and I could choose edit, and then every 15 minutes. I want to be totally bugged by these people. Be the first one to respond. I think every day is good. I don't know. Maybe I'll go with every 15 minutes, because then it's like I could really be the first one to respond. And
but you're going to be inundated. I mean, there's thousands of these.
Well, Go isn't too fast.
Okay.
Maybe every 3 hours.
So it says there's like 12,000 questions, but that's been a while.
Yeah, since like 2000, whatever. Maybe I'll do every 3 hours. Yeah, we'll be reasonable about it. So email updates. I'm not sure where you'd find that in user settings, because I was just looking for that, and I I don't want to go dig around in there, but all right. So anyhow, that's Stack Overflow, and I've got 8 pluses here. How to listen to a client continuously using Gob. You've earned the teacher badge. Answer a question with a score of 1 or more for how to listen. I've earned some interesting privileges. I don't know what this is. Welcome to Stack. Take 2-minute site tour to earn your first badge. So they want me to do a tour.
That's 13 questions per day average on Go.
13 questions per day. So that's pretty good. That's reasonable. Where'd you find the stats? You're like the Stack Overflow expert, man.
No.
Where do I go to see that?
I clicked on the change email updates. It was somewhere.
Edit?
Maybe. Oh, there it is on the right. See?
Oh, right here. 13 questions per day average. Only 33 users following. Wow. 557 email subscribers. So that's pretty cool. So let's take a look at some of the stuff that I'm going to keep that email in case I want to get back there. Class, this is the email. And so here is the question that I really liked. And the question was, okay, it's hard to describe it in words, but let's say I have a map that stores int pointers. All right, int pointers, right? And I want to store the result of an operation as another key in my hash. So the map is storing int pointers. So these are addresses right here. And then dereferencing the address to get the value. And then adding the values together. And then getting the result of that. And then taking the address of that. And then this is the map where he's storing pointers to an int. So right here he's saying, hey, at this key, give me an int that's going to be an address and dereference it. So I just have the value. And then take that value and add it to this value. And then take the address of that. So this is a map. And it takes a key, which is a string. So here's an example of one key. Here's an example of another key. And it returns an int, or the value that's associated with that key is an int, but it's the memory address where an int is stored. So we should get a memory address with that lookup right there. This map, this key, give me a value, gives me a memory address where an int's stored, and then we dereference it with that, which says give me the value at that memory address, and then with each of those values, we add them together, and we get another value, and then we take the address of that. This doesn't work and gives me the error. Cannot take the address of this chunk. Any thoughts? So do you guys have any thoughts on that? So let's just simplify this chunk right here. And let's say it's 2 plus 4. Can you take the address of 2 plus 4? That's going to be 6. Can you take the address of the number 6?
You have to create a new location, a new variable that's another.
Yeah, so the number 6 may not be allocated yet. That could just be part of like, okay, I'm stored in the registers of the CPU. I added 4 plus 2 and I got 6. And it's not like it's a variable. And it's not like y equals 6 yet. It's just the number 6. And so that's a constant. And it's constants in Go are constants of a kind, which means their type is undetermined yet. Right? And so we don't even know if it's an int. It's just a number. And then when it becomes an int, it doesn't necessarily have an address yet. So here's the answer. And I really like this answer. And so I'm just sharing this to teach and show you guys, like as you're continuing to learn this language, and we part ways in this class, like Stack Overflow is an awesome place to continue to learn. One, by posting questions when you're stuck and, hey, can I get help? And I'll be one of the dudes. I might see your question. Right? And I'll be like, oh yeah, check this out, remember? Or 2 is to read other people's questions, and see what answers are provided. And so here's the answer that's provided, and I thought is instructive. And it helped me get clear on something which wasn't clear for me before. A pointer is a memory address. For example, a variable has an address in memory. We know that, right? Pointer's a memory address. Points to, hey, this location in memory. And a variable has an address. So y equals 12, that's going to be stored somewhere. The result of an operation like 3 plus 4 does not have an address because there's no specific memory allocated for it. It's not like we said store this variable is y, it's an int, and store this value in it, in which case we had to allocate memory. Does that make sense? Memory allocation, right? Like, what is memory? Memory's RAM. Okay, we're allocating it. We're giving it a box, little place where that value is going to be stored. And then we have the memory address for that. The result may just live in the processor register. So 3 plus 4, doesn't have an address because no memory's been allocated for it. The result may just be living in the registers. Interesting, huh?
But it is being assigned to D, and so it's going to end up in.
Well, this is his example of the answer.
Okay,
Here,
but
nothing was assigned right here. It wasn't assigned to any variable. It's just 3 plus 4 right
what's
there.
the MD on the left side?
Well, that is the address which is trying to be assigned. Trying to assign to this key a value which is an address, right? And we're trying to take the address of 3 plus 4.
So you just take away the ampersand, and it'll assign the answer to D, right?
Yeah, but then you'll be storing a value in D and not a pointer to an int.
Right.
And it's defined that you need a pointer here. You need an address.
Okay.
Yeah.
But then, can't you just then assign it to D is what? D is
the key.
Okay. In a map. And so then can't you just assign it to D and then take the address of that? And
But what a map is an address in and of itself, right? So we could take the address of the map. I don't know if you could take the address of something that's stored here. And that's just a convoluted wrong way to do it anyhow, right? Because what we want to store in this map is a pointer to an int, and we wouldn't be storing a pointer to an int there. You could take the address of an entire map, I believe. I mean, we could play with that. So let's check it out. I mean, this is the way to answer every question: is can you actually do it? So here we go, and we have a map. And it's going to store an int, a string and int. And so then how do we make entry in the map? How would I make an entry? Tell me what to type. Or not. Is that right? How do I print that out? Is that right? What's going to print?
It's going to print 1. The number
1. 1. Can I now do this? I don't know. And it just says, hey, this is a map. It doesn't actually give me the memory address, but there's my map and it's showing me the map. Can I do this? Dereference that? There, I was able to dereference it.
What happens if you just print M by itself?
Just the map, same as reference, dereference. And what if I try to take the map or the address of 1? So I'm trying to take the address of the value. That's wacky. We'll see what happens. And then let's take those out for a second. Which is interesting. I don't know what happened to my question. Right here. All right. So here is the answer, right? So you have this. X and Y are both equal to 1 and 2. X is 1, Y is 2. And then a string and a pointer to an int. And, a map literal where we're saying x is the address, because that's what we're storing it. Some string is the key, and then we have a pointer to an int, right? And then we're dereferencing each of those. So we're going to add 1 plus 2, and we get the value 3. So this is pretty similar to what you're kind of thinking, Bob. And then we take the address of that, and we could store it into, this takes a key and a pointer to an int. And then we could print that key, the pointer to the int, and we could dereference it right there. So here we get the address, and we print that, because that's what's stored there. That's what's stored there. That's what's stored there is the pointer to the int, or the address where an int is stored. And then when we dereference it with this right there operator, we get that. And that's an operator, dereference. And this is part of the type. Okay? No, that's a dereference right there. This is part of the type. That's an operator. So when you see that, a pointer to an int is a type. When you do that, that's a dereference. That's an operator. So even though they're the same symbol, it's kind of like the plus sign can either be an operator, or I'm not sure. It could add two numbers together. And what is it when it concatenates? That's also an operator.
Yeah, but a minus sign can be either one. A negative number, it can be part of a negative number, or it can be an operator.
Mm-hmm. Yeah, that's right. Negative number could be part of, it could be an operator, or it could be a sign, right? Plus or minus. Thank you, that's a good example. It took a second for that to process in my head. If the code above is in a function, the address of the local variable that we just put into the map will continue to live even if we return from the function, right? So check that out. If the code is in a function, the address of the local variable, d, right here, that we just put into the map will continue to live even if we return from the function. That is, the map is returned or created outside, e.g. a global variable. So the map is returned or created outside. In Go, it's perfectly safe to take and return the address of a local variable. The compiler will analyze the code, and if the address pointer escapes the function, it will automatically be allocated on the heap and not on the stack. I just saw Bob's brow furrow a little bit. Like, what does that mean, right? And so escaping from the stack. So that's something that when I went to this training here, Arden Labs right here, Arden Labs Hardcore Go, run by Bill Kennedy, who is the author of Go in Action. Bill Kennedy. He's the author of, there's Bill. That is not Bill. I think that's Bobby Kennedy. So I'm just looking for the book. Amazon. There we go. He's the author of this book, Go in Action. All right, so when I went to that training, he talked a lot, or that's one of the points he made, was talking about variables escaping the stack. And so the stack is, as in Stack Overflow, maybe. Just thinking about that for a second. So the stack is when things are executing, they're being added onto the stack, right? So Golang-book.
The one that's last added first out.
Last in, first out, right? And Golang.book right here has let me just see if stack is in here. No. So it's probably going to be in functions. Maybe in here. And let's just see if it's here, stack. Ah, perfect. Okay. Functions are built up in a stack. Suppose we had this program. Func main calls function 1. Function 1 runs, and function 1 calls function 2. Function 2 runs and returns 1. So here's the stack. Main runs, calls function 1, right? So function 1 is now running on top of main, which calls function 2. Okay, function 2 is now running on top of function 1, which is running on top of main. Function 2 returns 1 and gives it to function 1. And then function 1 returns the result of function 2, right? Function 1 returns the result of function 2. So it returns, and that goes back to main, and then main prints it. So this is the stack. Functions are being added and removed from the stack.
Function 1 returns to the answer to the main function.
Right there. Function 1 returns, what function 1 returns is the result. So function 1 returns the result of function 2, which is 1, right? And then we print 1 right there, what function 1 returned. So this is adding functions to the stack and taking away. And what we learned about scope is that that's scope right there, right? So that's, this, any variables in function 1 are, the scope of that is right here. And so if from the compiler standpoint, if we're using values and variables in function 1, when function 1 is done, the compiler can throw all that away, right? It doesn't have to keep any of that. So everything is staying on the stack. And that's good from a performance standpoint because your garbage collector doesn't have to worry about figuring out, is this still being used or not being used? When your function is done, all of the values in it can be thrown away. And your garbage collector doesn't have to go clean those up. Does that make sense? But if you've taken the address of something on here, if you've taken the address of something and then returned the address, something else later might need to reference that thing stored at that location because you've returned the address and you're using the address. And so now that variable has escaped the stack. Does that make sense? Let me show you.
Because you've assigned it a location.
Let me show you.
Or because we've referenced the location where the
Because we've taken the address. So format that. Oh, I've got too many func mains here. Func main, and these need to come down here. And this needs to go away. Format, there we go. And so right here I'm going to do y colon equals 1, return y, and format that, and then run it, and it's 1. Okay? And so here, this variable, when this function is done, it no longer has to keep the memory address where this variable is stored, right? Because the scope of it was right here, and this function is done. You know, when we look at the stack, right, function 2 is done. We no longer have to worry about that. Could throw all that away. However, if we do this, and then this returns a pointer to an int, and then here we dereference it, right? Well, this just escaped the stack. Because now the location where this is stored, I'm returning that location, which means it might need to be used somewhere else. And so it went to some place called the heap. And the heap is what the garbage collector has to go through and try to figure out, is this still being used or not being used? And so that has a performance impact. So that's called escaping the stack. Right? And it's escaping the stack and going to the heap because we took the address.
Right.
Does that make sense?
Yeah, leave it there for a minute. I'll play with it.
Here, let me help you even more. Ready? Go there.
Okay.
Play.golang.org, p/p/ capital all that.
I'm already in the playground, so I just have to type that stuff.
All right, so I just ran this code and I realized, oh, it looks like I have an error. And it says, cannot use f2 type int as type pointer to an int return argument. But I'm returning a pointer to an int. And this, but what I didn't say here is this is returning a pointer to an int. So that's returning a pointer to an int too. So now let's run that and see if that fixes it. There we go, it fixed it. So I forgot to include that little dereference right there. No, that little type, that's part of the type. I forgot to include pointer to type right there.
It'll go out of the scope and
Yeah.
become a global variable in a sense.
Yeah. All right, so perfect. Exactly what Bob just said is that that's the takeaway from this is like there's this idea of the stack Whereas you execute functions which call functions which call functions, those get built up on the stack, and then as they unwind, they get pulled off of the stack. And keeping things on the stack is more performant, generally speaking. Okay, more performant. And there's an exception to that. We're going to see what that might be in just one moment here. And when you take the address of something, this is the main takeaway from what we're learning. So when you take the address of something, then that variable might be escaping the stack and going to something called the heap, right? And in the heap, then the garbage collector has to deal with whether or not is this being used and clean that up, and that's a performance hit. And so the main takeaway is, when do things escape the stack and go to the heap? And that's the general rule, is that when you take an address, that's a likely candidate that it might be escaping the stack and going to the heap. Now, that's a performance hit because the garbage collector has to deal with it if it goes to the heap, but it could also be a performance gain if you are taking the address of something. When could it be a performance gain? Why would you want to take the address of something? What does that allow us to do when we pass an address? It's allowing us to pass what versus what?
Reference of the value.
Yeah, so when we pass an address, we're passing just an address, right? And we're not passing all of the value. So if we have some huge value, like, you know, thousands and thousands or millions of entries in something, then, well, screw sending all those entries. That's a lot. I'm just going to pass the reference. For instance, you know, I don't know,
Making an object
United States
or
wiki,
big map.
right? I could send all of this to you right here. I could send you all of this, which is a pretty big document. You know, for a computer, no big deal, but just as an example, I could send you all of that, or I could send you this right here. I could send you the reference, or I could send you the value, right? And so when we pass a reference, we're passing less data, potentially. And this is where it gets on the edge of my understanding a little bit, but when we look at the Golang spec, we have make versus new, and this might be an effective Go, make versus new, make always, make. Let's look at effective Go. Make versus new. All right, allocation with make. So here we go. Make creates slices, maps, and channels. The reason for the distinction is that these three types, slices, maps, and channels, represent under the cover references to data structures. So slices, maps, and channels are already references. So I think, you know, that's where I get a little vague. Like, why would I take a reference of a reference? And when I did try to take a reference of a map, it just said, and, you know, map, right? It didn't give me the memory address. I wonder if it'd be that way with a slice, because they're already references. So if I have let's go to a new Golang playground. Oh, I can't click right there. Huh?
Slices, maps, and
Channels.
channels.
Yeah. I guess right here I could just create a slice. And so how do I make a slice? So there's my slice. There's my address for the slice. A lot like when I did an address for the map, right? It's not showing me an address, it's just saying ampersand. So I don't know if it makes sense to take addresses of slices, maps, and channels, because they are already references to data structures, which means, you know, it's an address where that data structure lives. And if we remember how slices are built on top of arrays, and a slice has a header value that the first value is a pointer to the array, you know, the second one is length, and the third is capacity. So just kind of interesting. And if we reread this now with that understanding, in the above function, the address of the local variable D right? If the code above is in a function, the address of the local variable d that we just put in the map will continue to live even if we return from the function, because we took the address right here, because it escaped the stack and went to the heap. In Go, it is perfectly safe to take and return the address of a local variable. So this was a local variable, local to the function, if it was inside a function. The computer will analyze the code, and if the address escapes the function, right, meaning, hey, something outside this function might want to use it, it will automatically be allocated on the heap, not on the stack. For details, see the FAQ on how do I know whether a variable is allocated on the heap or the stack. So if we look at that FAQ, the first thing they say is don't worry about it. Right? From a correctness standpoint, you don't need to know. Each variable in Go exists as long as there are references to it. The storage location chosen by the implementation, whether it's the stack or the heap, is irrelevant to the semantics of the language. The storage location does have an effect on writing efficient programs, however. When possible, the Go compiler will allocate variables that are local to a function in that function's stack frame, so on the stack. However, if the compiler cannot prove that the variable is not referenced after the function returns, then the compiler must allocate the variable on the garbage collected heap to avoid dangling pointer errors, meaning here's a pointer to nothing, right, that no longer exists, is destroyed. Also, if a local variable is very large, it might make more sense to store it on the heap rather than on the stack. And that's the thing where let's use a reference and pass a reference as opposed to this big variable.
So when you unmarshal a really large JSON file, you get a reference, right? You get a pointer, you know, to the value which has been unmarshaled.
I don't know. Let's take a look. So go doc.org. Where is the JSON package in GoDoc? How do we find it? So I go to godoc.org. How do I find the JSON package? What do I do? Type in JSON. I love it. JSON, encoding JSON. So it's at godoc.org, encoding JSON. And then you're wondering Unmarshal.
Yeah.
All right, so Unmarshal takes a slice of bytes and something of any type, and then returns an error.
But the V is a pointer, right?
So Unmarshal parses the JSON coded data and stores the results in the value pointed to by V. Yeah, so it stores the results in some struct or something, right? We pass in an address to a struct right here.
So the interface part, that's the type where the data is being stored. The V is a pointer? That value is a reference to that? Is that what that says there?
So if you want to see how we would use Unmarshal, let's see if they have an example here. Example Unmarshal. All right, so here we have a slice of bytes and a string literal. So what do they call that? Raw string literal. And then it looks like some JSON, right? A slice. And in that slice, we have an object. And in that object, we have key value pairs, key value pairs. Okay? And so then we create a struct. And that struct is going to have name and order to match each object here. And then we create a slice, var animal slice, to match this slice. Right? And then we say JSON unmarshal, JSON blob, animals. So the animal, animals is a slice of animal, and each animal is a struct. And so here we're unmarshaling into animals, right? This slice of objects or structs. And so that address, we're just passing the address here, and it fills up that memory location. And so then when we go to access anything at that location, it's got the data in it. It doesn't need the data structure, it just needs the locations. We're just giving it the location. There isn't a real performance gain here because that's empty. There's nothing there really, right? But it's just the way that this has been set up. The unmarshal function of the JSON package has been set up to take, you know, the address, to take a pointer to something. Does that answer your question? Do you remember your question?
I was thinking if there was a really big data structure, like census data.
Census data, huge, yeah.
Huge, yeah. We brought that in as a JSON file.
Well, when it comes in like this.
Yeah.
All right. So it's coming in from somewhere. It's coming in as a string. Because we don't have an access to the address on some server where we've asked for the data. So they're sending it over the network as a string. JSON. I think, that's my understanding of it. I do not have perfect knowledge. So I thought that was pretty cool, and that helped me sort of get clear on memory allocation, right? And how 3 plus 4, there's no variable. It's not being assigned a variable. Memory's not being allocated. And so that could just be in the processor registers. And then, so that was one of the things that I liked about this post. And then another thing I liked about it was stack versus heap, and just sort of exploring that a little bit more. Let me just see a show of hands. How many people that's been helpful to you? Okay, cool. Cool. Carson, your hand was up there?
Yeah.
You're kind of behind the left turn. I got to move this thing, man. There's now a big thing on the left turn that says, if you move this, put it back.
Is this how all languages do it, or just go
Yes.
stacks and heaps?
Oh, I don't know. It's different in different languages because, some languages could have dangling pointer errors, right? So you can return an address from a function. The function closes and it kills whatever is stored there, and then you have a pointer to nothing.
And then okay. But C++ definitely doesn't do that, I'm pretty sure.
Yeah, I think C and C++ wouldn't do it this way. So Go's the improved version.